All right, so here we go with 9.3, which is going to be one last section. 9.3 is matched paired testing. Now, what a matched paired test does is we do have quote-unquote two samples, but this time the samples are independent and they're related some way, and that's why we have a matched pairs design. And so what happens is we end up first comparing those two sample values together and then take those combined comparisons and run them through a single test or a single mean test using t-values, because we're still studying means. But the idea is, because these two are related, we're going to subtract both of those sample values first, get new sample values, and run those through a kind of simple, or almost what looks like a chapter 8 test statistic and confidence interval. So this follows the same confidence interval formula, test statistic formula, for a single mean test. It's just that we have that x bar of d because it's the difference between the two samples. The subtraction happens before the test, whereas when we have independent samples, the subtraction happens in the middle of the test. All right, so that being said, let me pull up my screen again. Please don't be my face. Cool. And here we go. All right, so we're going to show you how to do this in the calculator. Some of these get a little bit too insane to do with your calculator, and we're going to just rely on StatCrunch to get through your homework. But pay attention to the ones that we're only going to do in our calculator together, because those would be something I would expect you to do on an exam. All right, so because I've got the raw data this time, I'm going to, maybe I'll press second and plus sign and clear all my lists. I'm first going to type in all the data from my list. So my temperatures at 8 a.m., 97.9, 98.8, 97.2, 97.6, 97.8, and then for the others, 98.7, 99.4, 97.7, 97.2, and 98.1. All right, so we've got all of our data in the list. Let me just double check it really quick to make sure it's correct. And it looks like we're good. Awesome. All right, now let's see here. It says calculate the average difference between the two. Now I'm going to do some really clever stuff here on the calculator, because what I'm supposed to do is compare these two with each other. And I'm supposed to essentially say, let's take the temperatures before 8 a.m. and then the temperatures at 12 a.m. be the second sample, and let's subtract them in that first to second order. And again, the idea is that these are related. They all relate to 5 people, and that's why there's, essentially 5 different columns here, because each column represents one person. So that one person means these are no longer independent. And so here's how we're going to deal with that. We're going to subtract these two, and I'm going to make a third list. And notice what I'm doing is I'm highlighting L3 at the very top. When I click enter, I have a formula here. And what I can do is I can say I want to press the second button and number 1, because I want my third list to be every value from L1 subtracted by every value from L2. And there are my differences. What I can do now is I can say, well, I want stat, I want one variable statistics, and I don't need a frequency list, I want L3's statistics. And there's my average right there, negative 0.36. All right, and what's the standard deviation? We're always going to use the sample standard deviation, so be careful of that. That's going to be to 2 decimal places, 0.46. In general, what does this represent? It represents the difference, the mean of the differences from the population of matched data. I believe that sounds right. The mean value of the differences for the paired sample data. Never mind, that sounds a little bit better. Oh, never mind, because we're here to talk about the population, not the sample. Hello, that is a population variable. All right, there we go. Almost got me, but it didn't. All right, up next, let's see here. Well, the null always involves equality. And what do they want to compare this to? I guess we would assume that the mean difference would be 0. And we want to see that males speak fewer. All right, so if males go first, then that subtraction should be less than 0, right? Or in other words, men should be less than women. The first should be less than the second is how we would maybe say that. right? Because the men came first in the way this data was presented. All right, what I'm going to do is I'm going to go to stat, I'm going to edit, I'm going to pause the video, and I'm going to type all this data into my two lists. All right, so there's the data typed into L1 and L2, where the men is L1, the women's L2, and again, I'm going to show you the neat trick that I'm going to take L3, and I want L3 to be the difference of L1 and L2. And the main reason that this is so advantageous is because it would just take a lot more time to, subtract these two individually, get that number, write it down. Subtract these two individually, write that down. The calculator's doing all of that for us, and again, I can then press stat, and I can, let's even see what I'm going to do with this. Got my L3. I need to find a test statistic, so I'm going to do a t-test, a single t-test, because, again, we only really have one thing we're looking at, the difference between the two. We're only using L3. So this time, instead of using stats, I'm going to use data. And the null is, of course, 0. We thought it might be the same, but the alternative says that women speak less. Men speak less, women speak more. And our list is L3, be really careful. And the frequency list is 1, and again, it's that we think this is less than. All right, and our test statistic is negative 0.43 when we round that to 2 decimal places. The p-value is fairly large, to 3 decimal places, 0.341. And the p-value is definitely greater than, I don't even know what the significance level is, but that's a really big alpha, something that happens 34% of the time. That is not rare. So we will fail to reject, and there is not significant evidence to claim that men speak fewer. All right. Now, what's the confidence interval? Well, let's see here. We can go to stat. We can calculate a t interval, just a single interval. Again, from data, we're doing L3, frequency is 1, and let's see here. This time our confidence level, it is one-sided, doing 0.5 significance. I want to say that in this match pairs test, I guess we'll follow the rule before that. This is one-sided, so we should double that amount. Let's see if that's true, because I've never done this for a matched pairs before. Look at me, I'm learning something new, or at least recalling something new that I haven't done in a while. I think that rounds up. Hey look, it's one-sided, so double that alpha value. Alright, well, since the confidence interval contains 0, we can't reject the null hypothesis. That idea is showing up again. Alright, and I'm once again going to pause the video and show you how I typed in the data. Alright, so again, there's my L1 and L2. Now I'm going to do the magic of saying L3 is again L1 minus L2. Now L3 is the only list I care about, and that's really only one sample, so to speak. So we're going to construct a confidence interval. That's going to be a t interval. And let's see here. And we want to specifically reduce pain. So this is a one-sided test, and I'm reading that again because if they want a 95, actually I guess never mind, they're telling me they want 95% as it is. They aren't comparing it to some sort of alpha. Looks like I get 0.13 and 2.82. Right? Does it appear to be effective? It looks like it because my confidence interval is always positive. Or in other words, the after 95% confidence says that we can be 95% confident that after I receive, let's see here, looks like hypnosis, that my pain appears to be reduced. So 95% confident that after receiving the hypnosis that the pain is reduced. And that's, again, because the interval doesn't contain 0. This is a one-sided subtraction, which means the second group, or the after group, must be lower with 95% confidence. Okay, it doesn't, and it's always greater than 0. Cool. All right, we've got one more here that we're going to run through, and this time we're just going to show you again how can you use StatCrunch, because, well, here's why. No one wants to type that in by hand. All right. So first, let's see here. We want to test the claim that actresses tend to be younger, that the actresses tend to be younger than the actors. Okay, so the difference Let's see here. How are we doing the subtraction? So it's actor minus actress. All right. And of course, the null hypothesis always involves equality. We would assume that there would be no difference. But the alternative is saying that we think the actors, sorry, let me logically think through this. Actresses are younger. So if I do actor male minus actress female, then if females are younger, then that means that this subtraction should be positive because the males are older. So greater than 0. Okay. Now we're going to identify the test statistic, and let's see how StatCrunch can do this. Now, why haven't we been using StatCrunch at all? Well, because, again, you only get a graphing calculator, not StatCrunch, on your exam. Uh-oh. All right. Give me just a second here. Oh, no. I think it's going to take away the... I don't think I can go back. Give me a second here. So there's StatCrunch. How do I leave? Home? No. So we've messed up everything. How do I go back to that homework problem and make sure it's the same homework problem? Let me see. I think it's going to change things. And it is. Those are probably different data values now. 30, 49. Whatever, we're going to assume they are. Okay, I know how to fix this issue. Anyways, okay. Equals 0, greater than 0. And what's the test statistic? Okay, so first we're going to click this, and then we're going to press open frame in new tab. There we go. Open frame in new window. All right, we figured it out this time. So let's see, what can I do here? I can do a stat. I think I can even just do a a paired stats test, and we can do actor, and then actress, and look at that. We can choose our hypotheses. That the subtraction was greater, and were we doing hypotheses or a confidence interval? We were doing a test. Okay. So hypothesis test, and the significance level. Let's just compute and see what happens. Okay, so it looks like our test statistic, goodness, juggle the windows, is 4.53. The p-value is very small, it's essentially 0. And the p-value is definitely less than, so we will reject the null because there is evidence. And is that it? Oh no, we have to do the confidence interval. Okay, so now we're going to go back, and we're going to, again, say that we want to do some statistics. We want to do a t-test. It's paired, still actor, then actress, and this time we're doing a confidence interval. And because the subtraction is one-sided, and we're doing 10% significance, we're going to have to double that and say I want 80% confidence. So 80% is, again, what you get when you do 100% minus double that significance level of the test, because this is one-sided subtraction. Let's compute that. And we have a lower limit and upper limit now. So the confidence interval is between, to 1 decimal place, 5.5. And 9, that actually rounds to 10 once you round it to 1 decimal place. There we go. All right, the confidence interval concludes only positive values, so that means we're going to reject HO. All right, and that does it for all of Chapter 9 homework. So I hope you found this insightful. I hope it helps you as you go through your homework, seeing as we went through it together, so to speak. So your numbers will change, but the ideas won't. And have a great week, everyone.